Good morning. Oops. I managed to do that. Okay. Today is Thursday, the 30th of August, 2018. This is the nybbles.io daily programming stream. My name is Jeff. I write code every day and I stream here on Twitch Monday to Friday. I'm working on a project called Basecode, which is a new programming language that will destroy web development. That's my evil plan. Shh, don't tell anybody. So, yesterday, I made some progress on and off throughout the day and pretty happy where things left off. So let's go through some of those. Let's look at the sample program I'm testing here. So this is for testing the inline assembly, but I also have now added in tests for the size of Intrinsic, which is working. Hey, it's a coder's life. And okay, so where I left off yesterday was I was testing the compiler's going to generate bytecode for this. Then we have some inline assembly. Labels are now working. I fixed some other bugs. Or in the parser, minor little state issues. And then code that's going to be generated by the compiler. What the? That was weird. Code that's going to be generated after. And then I even had to use the inline assembly to kind of monkey patch around. Hey, Synox, excuse me, an issue with the compiler itself, which works. One thing I meant to test, though, I didn't test. I think that should be okay without the cast. So this all works now, and there are a lot of cleanup, a lot of refactoring, and I'll go through that. Why does this thing keep doing this? I don't, it bothers me. Why is it doing that? So, if we look real quick at The output, this is correct. So the size of intrinsic is working, and we can even get the size of composite types, and that's correct. So that's woohoo, really cool. So now, hey Dot Dreams, if we look, I put some comments around the inline assembly blocks so they kind of stand out. But you know, I can use labels and it resolves that. Everything else works. I can actually change the value of that variable and it's correct. Now, a couple things. One, because of the way I'm naming things, when I create the assembly output, things are not being, like namespaces and stuff are not being included in the labels yet. So I may have to make a trip back around to this code when I do in fact start like fully namespacing things. Because really what should be happening here is, I think it would be like module block 81 underscore blah, 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 right? Because you could have a foo and a foo in two different modules. They're both valid within their scope. Haven't gotten to that yet, but I probably will have to swing back around to fix this when I do that. But we can see here also that now the sequencing of the code is correct. So this is compiler generated code. This is what I wrote manually in the assembly block. This is more compiler generated code here, even more compiler generated code here. And then, yeah, so then we come down here and you'll see this intrinsic constant fold and it has a value of 1. That's the size of foo, and foo is a byte. And then you'll see we do a print, then we get an intrinsic constant fold with a 2. That's because the U16 is 2 bytes. Then we get 4 because the U32 is 4. Now, I discovered a bug, and this only applies to foreign function stuff. I was thinking about that the other day. Hey, Super Circuits. Welcome. But the issue is, again, the way that the interpreter works is everything is a 64-bit field. You can think of it that way. So registers are always 64 bits in size, but the size specifier tells the interpreter what part of the entire register we want to manipulate. And for things that are internal to the interpreter, that's fine. But externally, when we push things on the stack to make a foreign function call, we are putting the entire 64-bit value, whatever's in that register, is going on the stack. So if there were other larger values in that, like in the case of some addresses and things, the upper bits are going to be set, which cause problems. So in the case of FFI, I'm going to have to make sure I reset registers before they're used, essentially. So this was like the first practical use of inline assembly here. I was able to fix the problem by just clearing out the temp register I knew that was being used, and that fixed that issue temporarily. So woohoo! I got something practical out of it, but yeah, it's a bug in the compiler. So for FFI, I'm just going to have to, I don't know, we'll eventually come back to that, but essentially whatever register gets allocated for a temporary value, either we'll do a move Z, which would be a zero extended, or I don't know, or we'll clear it explicitly like I'm doing with the inline assembly, one or the other. So that was a small bug that I found, but all this works, and the sequencing is all fixed. It does exactly what it should. You can now intersperse inline assembly in regular compiled code. You can reference variables, and pretty cool. So made a bunch of changes to, so let's take a look at instruction block. So instruction block, okay, so you have an instruction block, you have the assembler. The assembler has blocks. Blocks have entries in them. The entries are a variety of different things. I am writing a compiler called Basecode for a programming language called Basecode that I'm designing. And so that's what I'm working on right now. I am writing my own language, yes. So let's see, where was I? So right now an instruction block can have a section entry, it can have a data definition entry, and that goes for initialized or uninitialized data definitions. It can have an alignment directive. Now, what I used to have was on the block entry, a block entry had labels and it had comments, and I just broke all that down and I just said that's kind of silly. So now there's an entry type for comment, there's an entry type for a label. Actually, I don't think I need this type def anymore, so I can get rid of that. And I fixed the copy constructor issue with the block entry. I was kind of fighting with that when I ended the stream yesterday. But blocks now are just, they're standalone. A compiler, or the assembler rather, just has a list of blocks. There's no hierarchy, there's no relationship between blocks. When you create a block, it just has a type, and that's it. And then, because now blank lines, comments, labels, those are all entries in a block now. I moved those helper functions from the entry to the block. So you can just create blank lines, you can set your labels, you can create comments now on the block. And those work exactly like they used to, it's just that now they live on the block. So all the code I had where I was saying, oh, is there a current entry? No, there isn't. Create something. And all that stuff's gone. So much, much cleaner. And like I say, blocks don't have any relationship to each other. The assembler owns the collection of blocks. One thing I did was I added a flag to instruction block that can be set manually to indicate whether or not a given block should emit code. And this is helpful because in the case like with inline assembly, and I'm sure we'll end up using this feature elsewhere, we want to sometimes generate blocks and then defer or copy that the contents of that block into other blocks and not have them generate anything on their own. So there were a bunch of things that came off of block, adding and removing other blocks to them, the hierarchy, clearing things out related to blocks, all that good stuff. Instruction block used to have a bunch of behavior on it around labels, which that all moved to the assembler. And because the assembler now owns the collection of blocks directly, dealing with looking things up and all that is much, much cleaner. than it used to be. Always love it when I can make things cleaner. So things like find in blocks, make label ref, make label, find label ref, find label, these all came from instruction block over to assembler, and resolve labels, a bunch of other stuff. And then the collections that instruction block used to have for labels and all that stuff moved over into assembler, which makes much more sense because the assembler owns that. If you think of the assembler as like the global scope for whatever it is you're assembling, it should own all that. Now, it turns out that the current natural block creation order by the compiler is correct, but meaning that I don't have to do any special ordering at the moment to get blocks to come out the way I intend for them to come out. However, I don't think that's going to be permanent. So I think what I'll do is I'll be adding another collection into assembler. Instruction block now has an ID on it that comes from the ID pool. And this collection that I'm going to add will be probably will be a map of some kind. I don't know. I haven't quite thought about it, but it's going to be an index essentially. And that index is what I'll have an API for it, where you can essentially say, hey, take this block and put it before that block, or take this block and move it here, right? And you can reorder things, and that'll be the vector of instruction block pointers will be the original creation order, and so they'll always be inserted in the order they were created. And this is the ownership collection. In other words, this is the list of pointers that need to be managed in terms of life cycle. The ordering collection will just be an index into this, and then I'll just change the code to use that ordering structure to dictate how you walk through the list of blocks. And then that way, I'll have complete and total control over ordering. But like I say, interestingly enough, I didn't get rid of that. I didn't need to do anything like that to start. Now the assembler still has a block stack because that's still a convenient mechanism when we're actually doing compilation in some cases. And this is not an ownership thing. Again, this is just an index. So after I cleaned everything else up, I didn't see any issues in keeping that around. And like I say, it does work in the context of the actual compilation. A couple other things I did in the from source. In the inline assembler, let's see, for the mnemonic, I changed, or I'm sorry, it wasn't the mnemonic. It was the operands for the mnemonic. So I changed the way the parsing here worked a little bit because I wanted to support labels. And so I restructured this and then ultimately ended up with support for encoding label references in the inline assembly. There is one issue with this, which, I don't know. Right now, it's not a huge deal, but I did kind of run into it accidentally. The parser will accept a leading digit as a label. It'll think it's a label because you don't have the immediate symbol. So I just need to add some code in there to check, hey, okay, if we fall down to this case, is it an alpha or is it an underscore? If it's one of those, then we're okay. Otherwise, it's an error. And then in the, which one? Yeah, in the mnemonic opcode state, where we're parsing the opcode, the parameters for a mnemonic, this needed to do a retry. It was skipping a character in the source file, which was causing some problems. So I fixed that. I'm curious, I never did measure it. So the entire inline assembler is inside this method. At some point, I need to refactor this. But I have other ideas on that too. So the inline assembler ended up being 542 lines. So I would say that's the bulk of this file at this point. But that's not too bad. It's pretty functional for as simple as it is. So anyway, that cleaned up a ton of stuff. And also I had, because of the way I was doing comments and labels, it was weird. The control wasn't the way I wanted it. Now that I've restructured all that, literally the order in which you generate things on the block is the order they come out. So that fixed a lot of little weird bugs with where comments appeared, where line breaks appeared in the disassembly output. Obviously, none of that impacts runtime, but for debugging, it's nice to be able to kind of have a consistent output. So all that stuff's super clean now, works great. And then I said to myself, okay, so the inline assembler is looking pretty good. I would love to get one compiler intrinsic working. So I created the size of intrinsic. So size of takes an expression, and that expression, if it has a type, it will tell you what the size of that type is in bytes. Now, so I have two kinds of intrinsics. One that is a compile time constant intrinsic, like size of. So it looks like a function, looks like a procedure that you're calling, but this is it's a compiler procedure. I guess you could look at it that way, or compile time procedure. So what ends up happening is this gets folded into the integer constant for that, whatever that size is. So the size of intrinsic overrides two parts, the unfold and the infer type. So for infer type, it just says, hey, it's a 32-bit integer, unsigned. For the fold, we have because the intrinsics are created at the point of where a procedure call is being generated in the model. So you either get an intrinsic or you get an actual procedure call. It's we pass the argument list, a similar set of metadata that we get here. So we get the elements from the argument list, we infer the type of it, the first argument, and then we make an integer constant and ask the type, hey, what's the size in bytes? Pretty easy. Now, the issue, not an issue, just more, I got to think of how I'm going to do this cleanly, is, I don't know, an argument list, because right now there's nothing in the AST evaluator that is invoking fold on these. And I'll come back to that because I think this ultimately needs to move up into the evaluator somewhere. But temporarily what I did was in the code emit for the argument list, because that's where I'm using it right now. If it's an intrinsic, then I fold it, and if I get a folded expression back, then I put some comments in the instruction block and I swap the pointer so that the rest of the argument list emit code will consider the new constant value that got created in this case. And that works. But I think if I do something like this, that is probably not going to do anything. Actually, take that back. That one might be okay because that's a direct assignment. But we'll try both. I think if I put it in like a binary operator or a unary operator, it won't be folded properly. So I need to think about, then this swings back to the whole constant folding thing. I never really plumbed that in completely the way that it should be. So I need to do that. Excuse me. So the other kind of intrinsic is an actual code generating intrinsic like alloc and free. Interestingly enough, alloc and free those are the names of the instructions that'll be created in that case. But it's the same basic idea. We create an intrinsic, we add it to the factory, and yeah, it's not. It's getting the address of temp, and it knows it has to store something, but the store part isn't happening. This isn't getting folded. So, and I kind of suspected that was going to be the case. And I think actually part of why that isn't being folded might be because this is not telling the compiler it's constant, which it is. Perplexed blackout. I was wondering, do you think it's possible to translate human DNA into computer code? Sure. It's base 5, right? Is that right? No. It's more than that. I don't know. It's just some larger base, right? It's just not base 2. But yeah, I mean, you could take anything that we do now and encode it in a higher base, and then you just have to have some model of computation. I mean, theoretically, ignoring the fact that it's DNA, it's just a storage medium, right? So, there's 5 pairs, right? Yeah, so say it's base 5. I don't, right off the top of my head, remember. But, yeah, you're just using a higher base. And assuming you had a mechanism that could non-destructively read the DNA that repeatedly, then it's literally Turing's tape, right? Or who? Yeah, Turing. I think it was him. Or was it Babbage? I don't know. I can't remember. One of those guys, right? Computer is a device that reads instructions off of a infinite tape, kind of a deal. So at that point, DNA is not, there's nothing special about DNA. It's just an encoding mechanism. It's just a medium that you're using to store the information. So, but I can tell you that I don't think we have the technology to continuously non-destructively read strands of DNA without, yeah, we don't have that. I think we might have technology that can decompose DNA on the fly at some rate, but it's a destructive process. Yeah, exactly, right? So, right. So I think theoretically the answer is yes. Practically, there's no way to do it. So but here's the thing though, see, okay, ask yourself this question: what's different between DNA in your scenario and a memory stick, a USB memory key, right? There's no difference. They're identical, right? The only difference is that DNA is smaller, and you could probably collapse far more information into the, well, but again, I'm presuming here that once you have technology that allows you to use DNA as if it were a memory stick, then we presumably would have gotten past the issues of being able to either read the DNA and re-encode it on the fly, so it's non-destructive, although copied, which I guess technically is what the body does, right? Or we can actually read and modify DNA sequences on the fly seamlessly through some technological means that don't yet exist. At that point, DNA is no different than RAM or flash or anything else. Now, again, we can argue that it's a far more compact medium, and it has a higher base encoding, so we could probably encode a lot more data in a lot less space. Cool, that's awesome. But those are just enhancements. Behaviorally, it's identical to any other, storage medium. So putting a key on there doesn't, you're thinking there's something magical about the DNA that's going to protect your key. It won't. It's just bits. It just happens to be a much more collapsed storage medium. That's all. Just theoretically, and I guess not even really theoretically, we have some examples of this. We have CRISPR. I'm not implying that CRISPR is correct or doesn't have centuries to go before it's really practical. But, case in point, we can now, on some level, screw up your DNA, right? So, yeah, there's no intrinsic security there, I guess is where I'm going with it. Yeah, there you go, right? Play it back in your brain. Yeah. So, honestly, for cryptography, and this is total speculation, but you're really looking for some kind of, and again, we don't have this, and we don't, we can only speculate about this, but, and I'm going to talk science fiction here for a second, but in a lot of science fiction, you have this concept of deadlocking, right? Doctor Who and Star Trek has sort of their equivalent of it, and other science fictions have similar concepts, right? Slightly different names, but deadlocking is implied to be some kind of quantum state that is, it's the, not to like reuse my own name, but it implies that it's literally built out of the base code of the universe, right? It's literally built out of the building blocks of reality. And because of that, right, you can't, it's a key that just is, right? It's a lock that just is. It's not, you can't thwart it because it just perpetually exists. And then of course, presumably the key is some kind of retroactive mechanism that removes that. So to me, when you're talking about like cryptography and wanting something to store data that you don't want anybody else to ever get, I think ultimately we're going to discover that that's going to have to be some kind of quantum something or other. I don't know what that would be. I don't think anybody does. But at some point, I guess what I'm saying is you're literally engineering reality on some level there because you want that information to be secret, completely unavailable to anyone except those who have the key. So anyway, that's when I think down the future and I think, okay, well, what would that be? That's the kind of thing that, occurs to me. Watching you motivates me to program. Cool. Yeah, I mean, technically, I would say, excuse me, that the DNA RNA mechanism is a kind of metaprogramming. Sure, absolutely. I mean, obviously, I think our understanding of that is still very primordial, but it's certainly a code generator, right? And even if that code generation is limited to conception, to procreation, it certainly seems like that's at least one major component of that system. Does this compile into JavaScript? No. I do have intentions to support WebAssembly. It is a target that I want to have, but it'll never cross-compile into JavaScript. At least I don't intend to write that. If somebody else wants to write something that does that, you could, but oh, right. I was going to check and see if it's after bar. Ah, okay. Yep. Okay, that fixed that. Good. So let me do this. Okay, so it does work in the case of assignment, at least constant assignment. Let's see if it works for binary operator. Yeah. No. So there's doesn't work in this case. All right. Because I know why. This is skipping. Yeah, this is skipping the fold. So, okay. Yeah, so there's some bugs. So today, Alec, intrinsic, I wanted to add the other kind of intrinsic. This is the one that's going to actually emit code. No one's giving me anything to, yeah. I assume you mean like what I did for gun games. Nobody else has asked me to do anything, so if somebody wants me to review something, I can certainly do that. Is it ready? All right. Yeah, send me a link and I'll pull it down and we can chat offline. All right, so temporarily, I'm using some if statements to do the factory. I'm going to refactor this, but oh, excuse me. Hey, Everex. Okay, so on instruction block, I added encodings for alloc and free. And okay, so in here, I think this is correct. So for the alloc intrinsic, this one's not doing a fold. This is a runtime thing, right? Because this is actually going to invoke the alloc instruction in the interpreter, which will allocate a memory block in the interpreter's heap and return a pointer to it in the target register. So presumably, this is a right-hand side of some left-hand side expression, or if there is no left-hand side, then it just goes into the bit bucket. Which reminds me, so we grab the current block from the stack, we grab the current target register, we grab the a reference to the elements inside of the argument list. We grab the first one. For now, I'm not doing any error checking here, but we should be. but I'm just going to assume the argument's there. And we get a register for it. If it's a variable, we need to clean up. We push our target or push this temporary register, right, that we've gotten. We emit the arg to it. We pop that target. Then we take the target that was in effect when we came into this emit, and we call alloc. So essentially we're going to get an alloc instruction with a size that has a target register, some integer target register that's related to a variable. And then the right-hand side is the temp register that's holding whatever's inside the expression, right? Whatever's inside the argument. So if the argument is a like a Boolean, or not Boolean, if it's like a binary expression, like 2 times size of something or other, that's kind of interesting because that's probably not going to fold. But yeah, this would have that value in it, the size. Okay. We'll start simple. Oops, forgot the include. That's a GCC thing. I can fix it. It's designated initializers. Let's see, instruction block 1207. Oh. It's a blank line. Yeah, it might have shuffled around. I don't know. Oh, wait. I think the line numbers are, that's weird. Yeah. Okay, I fixed it. We're just, yeah. Again, like, I don't understand why GCC doesn't just fix it, right? Just, you know the order's not right. They're giving you an error. So if you insist that the order has to be the other way, just change it. Why is it an error? Clang doesn't care. Anyway, I fixed it. When I push this up, it'll be corrected. I don't think I specifically put that flag in there. For some reason, the default though for GCC, at least at the, yeah. I'd have to look at the compiler flags I'm passing, but yeah, GCC is very anal about the ordering. I don't know why. Yeah, so GCC conforms by default, and Clang, you have to tell it to conform? I don't know. It's weird, right? Like, okay, let's see if we get some Cody minis. Okay. So we have a target register, which is good. All right. Look at that. Nice. Okay. So, because C++ does not support it officially does not support C designated initializers. I don't know why. And I keep telling myself to stop using them because it's this weird gray area, because the C++ compilers are C compilers, so they support it, but yeah, I don't know. It's the most bizarre thing ever, man. Like, it to me is a nice feature. I like it. I like being able to do that. I think it makes the code easier to read. But yeah. I really wish I understood C++ designated initializers. It apparently didn't make sense to the design committee to include it. Yep. Yeah, but see, so this is interesting, right? And I think this is like, it's just an evolutionary thing. Like this answer, they say C++ has constructors, but which is true, but even C++ is kind of moving away from explicit constructors for a lot of things. So I honestly, my guess is that, oh, here you go. Yep, here you go. Was accepted C++ 20 standard. This brings limited support for C99's designated initializers. Okay, so yeah, they're... Yeah. Yeah, it's like, don't even get me started. Something so simple. Yeah, it's ordering. Absolutely. It's ordering. Yeah. Do you want to see how I fixed it? It's so simple. Here's what I did. This is what I had. That's what I had. And that's what they want. But here's the weird part. Well, see, again, the standard, it says ordering is important. Okay, fine. But Clang obviously will just fix it for you, right? They just will change the order. And I personally think that's totally fine. You know, if the compiler knows that the order's wrong, then it just fixes it. I don't understand why the standard is as strict as it is, right? Make it a warning if you want. Okay, so if the standard says order is important and I have high warning level turned on, then warn me that I'm being an idiot and that the order is wrong, but the compiler is going to fix it. But don't just die, right? Yeah, I don't know. I mean, I guess in one way I should be thankful because it's like a check. People compile it with GCC and it's more strict, and then I have to like go back and visit the code again, but it is kind of annoying. Yeah, GCC should not default to burn the world down if the order's wrong, right? Yeah. I used GCC for a long chunk of this project, but GCC doesn't work very well in OS 10, and I am working on a compiler for a language I'm designing called Basecode. Yep. Well, yeah, the compiler knows what the right order is, so it can give you an error that the order is not right. So, so fix it, right? I mean, that's one of those things where if it's really, that to me, it's like a Rust thing almost. That's like, hey, we have this detail under the hood that says we want to do it in this order, but we're going to expose that reality to you because, right? But at the same time, we have all the data we need to actually emit everything in the right order because we already know that, but we're not going to do that, right? Although Clang does. So obviously the people working on Clang, think like I do, I guess, and say, well, we have all the data we need to do this right. Let's just do it right. Right, exactly. Well, and I think I have like the highest warning level turned on, so it's pedantic, I get it, but it's like, oh my gosh, seriously, it doesn't. Clang doesn't seem to have an issue with it. Or who knows, maybe Clang's broken, I don't know, but I don't think so. No, it works, but the debugger doesn't work. The GCC 8 and up debuggers are not compatible with the current versions of OS 10. They just don't work right. There are some goofy ass workarounds, changing kernel extensions and shit. It's just a pain in the ass. So for months, I used GCC 8 and suffered because the debugging experience was horrible. And I got tired of it. So I dumped all the stuff that was making me, sticking me in the GCC 8 camp to begin with. I downgraded it, went back to Boost, and now the thing compiles very happily with earlier versions of Clang, and I get a better debugging experience because the Clang debugger is supported by Apple. It runs. Boost does not bother me. I don't understand why people hate it. I guess it does impact compile time, but like I've been writing C++ code for so long, I am used to it being slow. Do I want it to be slow? No, this is why I'm writing a compiler. It's going to be a lot faster, but at this point, I'm just used to it, right? And Boost gives me something I can't have otherwise. It gives me functionality that I want without having to run into the problem that I ran into by having to use the most bleeding edge version of some compiler that major operating systems don't support fully. So yeah, but you would be amazed at how many people tell me I'm an idiot for using Boost because it's so slow, and oh my God, how can you suffer through that? And why aren't you just using the file system stuff that's in C++ 17? Because nobody supports it except GCC 8.1. Why aren't you using the variant stuff that's in C++ 17? Because nobody supports it except GCC 8.1. And I can't run on the bleeding edge with all this stuff. That's right, damn it. Go back to DOS. No. What we should do is we should use Cyanox's new operating system. And we'll force it to do everything we want it sanely. Okay, so like C++ 20, great, that's wonderful. You realize that what that means is that the compilers won't support it until like 2025, right? So if you need networking, find a different solution. C++ 20 is not a good bet. Who knows what are they doing with modules? What is that going to be? When's it even going to be supported, right? Again, like this is one of the problems with C++. Like there's all this wonderful stuff that's out in the future. It's kind of like Fusion, right? We're always 50 years away from Fusion. C++ is always 10 years away from being awesome. And I've gotten to the point where I really discount all that stuff. It doesn't mean anything, right? Because until all the major compilers support it, it's not worth it. Oops, I didn't add it to the... And yeah, I'm just a grumpy old curmudgeon, but, Yeah, exactly. Always 10 years away from being replaced. No, try 2040. I don't know. Yeah, something like that. All right. No, you can't do that. GCC might complain about the order. Yeah, yeah. Well, and keep in mind, like, you know how that process works, right? It's in there, and then it won't be because something, right? Because Microsoft will complain that they have to, work even harder to keep Visual C++ up to date. It's costing them too much. And they can't get enough H1Bs. So they have to take that. They'll have to take those features out of the standard. Okay. Ka-ching. Wait, where'd my Alec go? There it is. Okay. So we get the address of adder. We move 4096 into I2. We allocate 4096. Oh, quad words. That's not right. Nah, that's not right. I gotta fix that. Yeah, that's not good. No. Not good. Let's fix that. 4096 times 8. Oops. Allocated 32K. For Alec, I'm just going to manually pass the size instead of inferring it from the registers because, yeah, this is one of those rare opcodes where I want to be able to control the size kind of independently from everything else. Cyanox, why are you telling them to use an OS? Just write it all in assembly language, reserve a bunch of memory, then there you go. Here's your memory management. You just got a big chunk of memory. It's yours. But then you got to figure everything else out, right? But hey. Or that. There we go. Okay. So we get the address of the variable that we're going to store the address in from the alloc. We move the size 4096 into I2. We call alloc for bytes. So we're going to allocate 4096 bytes. The pointer to that goes in I4, and we store that in the address variable. Then we're going to print out the contents of the address variable so we can see what that register was. Then we load the address register in, and we get the value from it, and then we free that pointer, and that's it. Oops, free is kind of the same issue, right? There we go. All right. That is sweet. So we've got an example of a compile time folded intrinsic working, and we've got code generating intrinsics working. So we can allocate now blocks of memory. Let me look at the address that's printed out. Adder is... Where's my print? Might be a bug. It's been a while since I've tested alloc and free. Not that I think anything should have changed, but okay, 4096, 4096. So we're going to call alloc with the size. Ooh, that's not good. Okay, yeah, that's not good. And of course, I don't have that trap set up, so we're not seeing it. think I know why. Uh-oh. Oh, crap. Yeah, I can't do it. There. Oh. I know where I can do it. Yeah, so the way the interpreter is intended to work, so we have a heap. At the top of the heap, we have a stack for the interpreter that grows down. And, okay, so what's our highest address? 1260. Okay. So we're going to go 1260. Okay. Yeah. All right, so now we're in alloc. We've got a heap block. Good. Now it's actually allocating memory. There you go. Boom. Okay. Yay. Problem fixed. So now we should have an address here. Address is 752. That seems low. Seems low. Okay, so, oh, it's fucking printf. God damn it. I swear. Every time. Ooh, no. That's a problem. Alright, I gotta take a really short break. I'll be right back. Okay. We have a problem. So in that one case, I want to override it. So what I did was I refactored set target operand value, so I'm not passing in a reference to the instruction. Instead, I'm passing the parts, and I'm passing the size. So for 99% of these, I'm passing in what the defaults were before. But in this one case with Alec, the mnemonic size specifier is actually being used to determine what the unit of allocation is. Are we allocating bytes, words, D words, quad words? We always know that the destination operand it's always a quad word, right? Because it's a pointer. So that can be assumed. But the way I had target operand value coded, it was assuming that the size from the instruction is always the size that should be used, which is in this one case not true. Okay, so now if I run it again, the address that gets printed out should be the correct address. That's a bug fix. Hey, Slayer Darth. Hey, Kubisis. Uh-oh. Stress is not good. Uh-oh. Yes. There you go. So that solves that. So, that's pretty cool. One step closer. Yeah, and I would say that if you've made your boss, if your boss is aware or you make them aware of this and they don't do anything, then there's something else going on, right? Hey, killing bird is a fish. How's it going? Awesome. All right. That all looks good. So let's review that. Okay, so I added a free intrinsic and an alloc intrinsic to the model. The alloc intrinsic inherits from intrinsic, and this is an example of an intrinsic that actually emits runtime code. It's not just a compiler constant thing. The implementation of alloc intrinsic is pretty straightforward. We grab whatever the current instruction block is on the stack. We grab whatever the current target register is. We grab the argument. I'm not doing any error validation here. I need to do that. We get a temporary register for the right-hand side. We emit the right-hand side, and then we emit the alloc instruction. And the size here, for now anyway, I'm going to presume that the size, the unit is always bytes, right? So we're always allocating size of bytes. And then the target register and the temp register from the right-hand side, or the whatever's inside the procedure call evaluation. The return type here is always a U64 because it's an address. And on assembler, I got rid of the type def because we don't need it anymore. And in assemble, I added a local variable and I just keep assigning the next address to it so that at the end of assemble, I can tell the interpreter, hey, here is where the heap free space begins, because I have to call this function because it's what actually allocates the initial entry in the tree for the heap allocator. Without this, the heap allocator fails. Element builder, I added makers for free intrinsic and alloc. These are pretty straightforward. Pull in the header files, create the elements, set things up, not too complex. Element types for declare free intrinsic and alloc intrinsic. Free intrinsic, very much the same as alloc, except he emits code. There is no target here because there's no left-hand side. In other words, like you could imagine free is void, doesn't return anything. So we evaluate the right-hand side or what's inside of the, the parentheses. and then we call free with whatever register is holding that. Excuse me. In my inline assembly test file, I got rid of the cast here because I realized I don't need it. Tested these. This works because now size of returns constant, or returns that it's constant, and add identifier or scope handles this one case. This case though, the folding isn't working, so I have to come back and revisit the folding stuff. And change the note here so I know that this is related to FFI, the fact that registers need to be cleared in some cases. And then down here, I added testing for our code generating intrinsic. So now we can call alloc, pass in an expression that is the size of how many of our bytes we want to allocate. That returns an address, and I print that address out, and then I call free, passing in that address. This is another intrinsic, and this actually frees that memory on the heap inside of the interpreter. Obviously, when this becomes native code, right, this will do native allocation stuff. Instruction block, got rid of a type def that we don't need, added in alloc and free. In intrinsic, in my little factory thing here, I now support alloc and free. I need to come up with a better way to do this, but for now the if statement is good for testing. In size of intrinsic, I override on as constant return true. That allows that one case to work properly. In the interpreter, I refactored set target operand value. So I was passing in a reference to the instruction that we're currently executing and the operand index that is the target operand. But the downside to that is there's cases where I want to override the size and some other things. So instead of passing in the whole instruction, now I just pass in the operand itself and then pass in the size, and that allows me to override what the size is. So in the case of alloc, the size here is always a quad word because we're always setting a pointer here, and we know what that size is and it's always fixed. In all the other cases, I just had to change the call to dereference the operand from the array here past the instruction size, so everything else behaves the way it used to. And then in the function itself, I can get rid of dereferencing the operand here because we're already passing it in, and then the size is whatever's passed in. And that is that. All right. So, air handle. some point I need to come up with some kind of constant thing for errors, so I can just go and say, hey, give me this error, and it's all, the numbers are all preset. Okay, let's test that. Also, I need to wire up a callback for the out of memory trap in the interpreter, because the interpreter was doing the right thing. I mean, it was attempting to call the callback for out of memory because it hadn't been set up to allocate memory, but I don't have the trap set up, so. Okay, so we didn't get an error here. So now let's break our test file. Let's not pass anything here. Oh, you know what? This is gonna blow up, I think. No? All right. So it did catch the error, but our location is off. So it's location. Oh, okay. Okay. So we got to pass the location through to the element. So when we use it to report the error, it is in the right spot. There we go. Good. Perfect. Oh, it's the last line. Yeah, it's a bug. I already have that. I have a bug for that. It doesn't format right if it's on the last line. And I gotta add error handling to size of, so do that. Yeah, perfect. change on fold, because this should return true or false, and then we should have some kind of result thing here that gets the element or whatever data we have to set on there. Oops. So let's butcher this one. Yeah. Okay, we're hitting this one. Oh, this one never. Shoot, I did the wrong one. Duh. Yeah, that one's not being evaluated. Oops. There we go. Yeah. All right. So I need to refactor fold. I need to refactor the API around fold. And then I think probably what I'm going to do for that is the easiest thing to do would be to just have a step in the compiler where I go through and I look for intrinsics, right? And I try to fold them globally, right? Because trying to do it piecemeal, it doesn't really make sense. So before we do code generation, so right now in session compile, we compile all the modules, we run the directives, we resolve unknown identifiers, unknown types, we do type checking. It's like after all this is done, then I'd have a new step here that would be, fold intrinsics, fold constant intrinsics or something. And it would just loop through, it would ask the element map, hey, give me all the intrinsics, and it would loop through and call fold on them, and if fold succeeds, then the substitution would take place, and then we'd go into code generation. So I think that's how I'm going to end up refactoring that. And I probably will have two different, steps. One thing that will fold intrinsics, because intrinsics are not optional, meaning that some of them, they have to fold into a constant because that's how they work. But like user constants that could be folded, those can be optional by using the no fold attribute. So I may have two paths for that. But I think I'll use the same technique for both. Awesome. So I would say alloc and free are working, at least for first pass. They're done. So let's review this. I added some blank lines because there's another bug. When I format the source error output and highlight, if it's the very last line, it doesn't get formatted properly. I have to fix that. In intrinsic, instead of passing in just the string, I pass the whole qualified symbol T reference. Excuse me, because there's a location, source location on this, and we can use that to pass that through so we can highlight things properly. So I pass that through, I create a pointer to the element we're going to potentially create, and then we assign that. If it's not null, we pass the location through and return that. Otherwise, if nothing happened, we return null. Had to include type here. Then I added error checking for free. So if we don't have any arguments, or we have more than one argument for this particular intrinsic, that's an error, right? And we issue an error and we bail. There's only one argument here, so we grab that and we say, what's its type? We infer its type. If we don't get a type, or it's not an integer, then that's an error, and we bail. AST evaluator, temporarily, I put some code in here to check, because again, I got to rework the API unfold. Eventually, this would be changed to be checking a Boolean response, and but I bail if this fails in this case. And that code's going to come out anyway, because if I refactor it all to happen as part of the compilation cycle, then that won't explicitly be necessary. In alloc intrinsic, I check for errors. So again, we only need one argument here. It could be an identifier, it could be an expression, whatever, but it just needs to be one argument. So if we don't have any, or there's more than one, that's an error. We infer the type of whatever that is, and if it's not an integer, then we're done. And then size of intrinsic, we need one argument here. The type of the argument is kind of the whole point, right? We don't need to constrain. We want to know what type it is, and then get the size of that type. And a line of, address of, type of, like those are all going to be very similar to size of. Type of is going to be kind of a special case, because then it starts getting into some of these other issues I have around like how I'm going to encode type information. But in terms of the intrinsic itself, it'll be fairly straightforward. Address of is kind of interesting. That one, we can't really do that until we do code emit. So I'm not exactly sure how I'm going to do that one quite yet. Maybe those have to be done. Yeah, I'm not sure how I'm going to do that. Ain't Magnum bag yet. Okay, so I need to they go. That's weird. Why is that an issue not showing up? Oh, that's why. I thought I said that. Maybe not. All right. So, yep, I'm gonna work on these today. I think I can get all this done, and that'll be huge. And then I can also finish off the rest of these, except maybe address of and type of might be partial, but I can structurally get them in there and recognized. I'm still noodling on type alias stuff. Yeah, so I'm thinking on those. These, I think I can actually execute on a lot of this and get more done. So, yeah, pretty good. Anybody have any questions? Interesting topics? So Hacker News linked to this guy's blog today. This was the blog post that was linked, and I'll tell you what, man. Like this guy, this Eric Dietrich, can't speak today. Like a lot of his stuff on his blog just totally, almost completely aligns with what's in my head. It's kind of scary. So I actually bought his book. So I'm going to read that. But he's got a lot of good stuff up here. So now I'm very much in agreement with a lot of what he points out as being problems. his, not really sure what I think of his conclusions or his solutions. That kind of feels like more marketing bullshit to me, unfortunately. Although, you know, I haven't really finished reading a lot of it yet either, so I'll reserve my final judgment on it. But just my, you know, top level assessment is he's pretty much spot on with a lot of what he highlights, but like, yeah, I got to read more to know if I kind of agree with where he wants to, or like what he's proposing. And ultimately, right, he's doing, hey, Ultra Hal 1 and Kanchan SX, he's proposing a lot of the same things that guys like Gary Vaynerchuk and other people of that ilk, right? John Sonmez, you know, stop calling yourself a programmer, don't be a programmer, don't be a techie, sell solutions. But of course the solutions are technical. Yeah, that stuff I'm less enthralled with, but yeah, well, and of course, part of what I find interesting about this particular guy's thoughts on some of this stuff is that, you know, part of why software developers maybe have such a hard time in the respect and authority category is because we're so dogmatically opposed to we identify so strongly, right, with the skill set. And I agree with that notion, you know, it's not wrong. It's, the question is, where I have problems is always in the solutions, right? Interesting story, right? So there's this other guy, his name is Ryan Wagner, I think. Ryan Wagner, yeah. This is Ryan Wagner. Yeah, this is the one. So, like, somehow I ended up on this guy's mailing list, and I just kept getting all this shit. And so finally, he sent a survey or something, and I replied, and I just, like, didn't hold back my feelings of what I thought of what he was offering. And the irony was that his response, like, he didn't disagree that most people would not be able to use the information he was providing because programmers are asocial typically, you know, not antisocial, but they're introverted. The small percentage that are extroverts that like to go out and do the sales thing is small, in my opinion. Anyway, we had an interesting email thing back and forth, and I thought it was very elucidating that he more or less, you know, agreed that the snake oil was not actionable for most developers. Yeah, I don't have pocket protector. I used to, years ago. Haven't had much need for my slide rule. Choosing a front-end framework. I thought we already had one. Fixing website. Laravel and Vue.js. C++ game engine development. Working on renderer. Compiler in Rust. I think I rated this guy the other day. It was interesting. I noticed that he told some folks that borrowing is hard. It is. I don't think this guy, he had music. I don't think he was narrating. Let's raid Brookzerker. He's got cool stuff. Okay, we're gonna raid Brookzerker. Say hi. I'll be back online tomorrow, 5 a.m. Pick up wherever I leave off. I think I should make some good progress finishing off the intrinsics, and then I don't know. I'll pick something else, and we'll keep chugging. And someday here, we'll get to a point where we can actually really start writing some fairly serious code, and yeah, go from there. So. All right. Everybody have a good day. Thanks for dropping by. I appreciate it. Had a ton of hosts and raids this morning, so that's all much appreciated. And yeah, I will be back online tomorrow morning. Here we go. Say hi to Brookzerker. I'll stick around for a short while. See you guys tomorrow. Bye.